Dear students, in our subject CAD/CAM Sim, we have seen the introduction to CAD/CAM and how the CAD/CAM Sim is very important and useful if we implement it in the industries. In the same way, we can see some of the elements of the CAD/CAM in the previous class. Now we are going to see what are the need for CAD/CAM in our day-to-day industry life. So, need of CAD/CAM. Here we have seen in the first introduction, it increase the productivity of the design, to improve the quality of the design, to improve communications, to create manufacturing database, to create and test tool paths and optimize them, to help in production, scheduling and MRP models, to have effective software control. These are all the need of CAD/CAM, because if we implement the CAD/CAM in the industries, we will benefit out of these categories. Here, the basic steps in the, or basic, not a basic steps, it will be the process in the design and manufacturing. Design manufacturing process is with sketch with pencils, engineering drawing with pencils, and manufacturing. In the manual process, we do these kind of steps for making one product, where if we implement these CAD/CAM into the system, these things are not required. We can directly move into the system with the help of software like AutoCAD Pro E, CATIA, SolidWorks, Solid Edge. The number of softwares available for computer-aided design and manufacturing, the CNC numerical controlled machines, CNC computerized numerical controlled machines. These are all the automated softwares which are all helpful for design and manufacturing. This is the olden technique. We are going to use this process. Then the elements of the design the process. Here we know that, as we told in the introduction to the CAD/CAM Sim, we have seen some of the topics like problem identifications, research phase, requirement specifications, concept generations, design phase, prototyping phase, system integration. Likewise, these are all the things we have need to design one process. Next is that content. What are all the basic this flowchart will give you introduction, basics of design, process structure, process flow diagram, equipment design, process control, waste, environment, safety, economic conclusions. These are all also the elements in designing the process, where we should know, or we should know about the introductions of the design. What design it is, what benefited, how to make this design. Next is basics of design. Basics of design is nothing but what the design depends on, what is the purpose or what are the applications we can use if we made this design. Likewise, the basics of design should know in the terms of geometrical, manufacturing, the machining, what are all the attributes available, we should know the basics of design. Process structure, in what way it is to be structured. First design, and then next to the design we have to make an synthesis, analyze the concept generation. What are the basic steps to be known before producing into a manufacturing. Process flow diagram. It means that the same way the process structure, we should mention first thing is to identify the problem, and then we have to find a solution for define that problem, to find some solution where we have to find the available resources in the scenario, we have to get and then make into that available sources into and design or the process. These are all the step-by-step requirements or the step-by-step procedure is called the process flow diagram. And then we have to make an equipment design. We should design or the equipment design, that is that particular product to be exactly designed based on that requirement. And then process control. How we able to control system, this is called system integration. How we able to control this design in a process way, and then the waste to be minimized or waste to be exhausted, and then it is to be very environmental free and also to be very safety one. And last we have to finalize or the economy. It is this product is okay or not, we have to finalize one and then conclude this design, and then we can go for the production phase. These are all the basic elements or the steps to design the process. Here, needs hierarchy. It means that where we implementing the CAD/CAM sim into the system. These are all the needs. High quality, portable, easy to use, low distractions, lightweight. These are all the things we needs for implementing CAD/CAM sim. Benefits of CAD/CAM. If we implement the CAD/CAM into one manufacturing industries, the benefits, these are all the following benefits. Productivity improvements in design. If the design is very accurate and the very good quality, automatically the productivity will get increased, right? Because the thing is in the manufacturing, design is very important. If we made a design the correct and the exact one, we can easily bring that design into a product. That's why if you give a correct design, example, if you take an example, whatever the process or the day-to-day life we are proceeding it, the first day it is to be a toughest one to follow it, and the day by day, for example, we daily coming to the college by 8 o'clock or 8:30, it will, in the earlier stage, it will be very difficult waking up earlier and to preparing earlier and to come to the college. If you get practiced, you can easily follow the steps daily. Likewise, if you make a design exactly the correct one in the first stage, then easily you can make the product a very successful one and also can improve the productivity. Shorter lead time. If you do a manual manufacturing process, takes a very time. In the olden days, the casting process, forging, the lathe operations, whatever the lathe drilling, whatever the operations are done in the olden days, it takes more time because the labor has to take importance in the work. The accuracy depends on the worker because no software or no systems is integrated. Everything will take more time to give one product. But if we use this CAD into your systems, you can easily sort out the time. Very short time we can design a product and we can make it component into the finalized component. Next one is design analysis. Before making into that design into a product, we can analyze the whole thing in all application, in all tests, where it will be suitable, where or how much load it will withstand, how much days failure mechanisms. These are all the things we can analyze. The design is okay, it will be benefited to the particular product or the, for example, we are making a small component to the engine, whether that component will easily shoot to that engine or assemble to that engine, or we have to make some modifications or optimizations in the design. We can analyze the design before making or going into the production stage. We can easily do. Next one is failure design errors. It is nothing but if any error comes out during this design step process, we can easily change it or easily modify it. We can easily identify or analyze some other solution for that design error and we can change. Easily find the product failure or the design failure at the particular time or the period of time through the software. So it easily can analyze or synthesize or can find out the design errors. flexibility in design is very important, because we can give a different flexibility in the design, because we are using software, so it can be easily we can change the geometric dimensions or some other parts in the design, so easily we can do it. That is called the flexibility in design. As we need or as the customer require, the design can be modified. Standardizations of design drafting and documentation. It is nothing but standardizations of design drafting. We can standardize the design draft before going into the production. We can standard that design and we can document the design using the softwares. Then drawings are more understandable, because we can view it in the two ways, 2D view and 3D view. 2D view will give out the full geometric views with the dimensions, where the centimeter or the millimeter or the inches, what we are giving as a measurement, we can see it in the 2D view. We can extract into that 2D view into a 3D view, the exact product into that 3D view. And nowadays more things have come out in the systems, like in the software, like artificial intelligence, IoT. Number of advanced techniques has been come. It will be helpful. And we can view the component of the product before we going into the production in an exact way as we see it in the hand. I mean, as see it in the produced the physical product. So we can understandable by these drawings. Improved procedure for engineering changes. We can easily collect the database or easily change any database as we required, either in the design drafting or in the geometrical models or whatever the need. You can easily make changes by the database or the documentations available. Benefits of manufacturing is computer-aided process planning, tools and fixture design. Computer-aided process planning is that we can plan the process, like we have two types of computer-aided process planning, the retrieval approach and the geometrical approach. Based on that approach, we can process or we can plan the process in step by step before or after the design, before the manufacturing. Tools and fixture design. Based on the tools and the fixture, we can modify or we can make a design. This is of benefit of CAD. Uses of CAD. Nowadays, not only in the mechanical streams, in all the engineering streams, the CAD is very benefited. Even in electronics, electricals, CAD is used to design a variety of different products, or variety of fields such as architecture, means in the constructions work or in the designing the infrastructures. These are where the places they are using these CAD softwares. Electronics, all the electronic component, like in the small speakers or TV, whatever electronic goods we are using, there are some more CAD systems or CAD softwares have been used. Automotive engineering, more mainly these systems have been used in the automotive engineering systems, industrial design, machinery, visual art, medical design. These are all the applications or the uses of CAD softwares. It is called computer integrated manufacturing. A computer integrated manufacturing is nothing but a process of integration of CAD, CAM and the business aspects of a factory. It attempts a complete attempts with all process functions under computer control. The combining of CAD plus CAM plus business aspects of factory is called SIM. Assessment. These are all some of the questions I have posted here. What is meant by SIM? Computer integrated manufacturing. It is combinations of CAD CAM. The need of CAD CAM. Why should the CAD CAM is needed? Given the improvements, productivity, leader, short lead time, quality of the design. These are all. Compare CAD CAM and SIM. Design, manufacturing and SIM. Thank you.